gallons of rainwater are wasted, despite that we have water shortages all over the world. Hey Jonas, read this. When it rains, Los Angeles sends billions of gallons of free liquid gold down the drain.
I can't believe it. Such a huge quantity of water wasted. Why don't we use it?
It's not easy. You must collect the water and clean it. Stormwater is contaminated and there's many bacteria crawling around. Water purification can be very expensive.
How expensive?
Well, you have to pay for huge machines, land, and energy.
Whoa, I never realized the time or expense of cleaning stormwater. Still, if we could clean it efficiently, it would help not just our community, but communities all around the world since it rains practically everywhere.
I can help with that, sir.
Whoa, who said that?
Oh, sorry to startle you. Cacti don't usually talk, do they?
No, they don't.
As I was saying, I can help. How? My roots can take water in and clean it, whether that's heavy metals or toxic contaminant from fertilizers or pesticides.
Cacti and other plants is a process called phytomediation to purify water. Currently, wetlands, marshes, and soil drainage systems are used to partially purify stormwater. In the soil drainage system, water is passed through plant roots, sand, and gravel before being collected in porous collection tubes to be sent off to reservoirs, rivers, and oceans. Larger sediments and some toxins are removed, leaving the rest to be filtered out later. A problem with the soil system is that it's poorly controlled. This can result in an unsuitable environment for the people affected by it. Luckily, our thorny friend can help us with that.
So the plant stem in our system will be above ground, but the plant roots will be in a container that will be placed in the purification tank. The walls of this porous plant root filter will have multiple holes to allow water in and out. The water will go through multiple of the chambers, each containing containers, to have maximum purification. Another chamber can be added where ultraviolet rays of sunlight can kill microbes in the water that the plants can't kill.
That's a great idea. These plant containers can treat stormwater anywhere around the globe, including rural areas where inexpensive clean water is needed the most.
Purification time using the plant filtration units can be optimized for effective water decontamination process.
Our system is modular and flexible. You can control when and how much water goes in and out at any time. In the soil system, water can only be purified when it rains.
One part I like is that it is inexpensive because there's a biofiltration method. Our research showed that the cost to install a biofiltration system that could purify 150,000 gallons of water per day would be less than $400,000. This is under 40% of the cost to install the conventional chemical treatment. Cost to maintain the system is $150 per month, 1/10 of the cost to maintain the chemical treatment system.
What's biofiltration?
Biofiltration is the process of purifying contaminant water, and this process is used all over the world. Contaminants in water, sucked in by plant roots, are accumulated inside the plant in its phytostructure and or degraded by the plant in its phytodegradation.
This process can help provide water to people who may not be able to afford it. Our research shows that the cost to install a small unit into a single-family home would be $500 or less for materials. Also, many types of plants can be used to purify the water. Our scientists will further explain.
This biofiltration method has been successfully implemented into areas such as Israel, India, Australia, New Jersey, and New York. But won't all these different places require plants other than cacti?
Indeed, scientists all over the world are researching to improve the process by identifying different plants and microbes.
Like bulrushes, which can remove oil and other organics from the water. Rushes also can remove heavy metals such as zinc, copper, or cobalt.
Our innovation can mitigate arsenic pollution of drinking and irrigation water if we use burn.
We shared our innovation with local stormwater professionals, a group of professionals from San Diego Water Authority, and school staff, teachers, students, family, and friends.
We discussed with stormwater expert Mr. Dan Biggs to identify a problem related to our research system. We visited North City Reclamation Plant to gain more knowledge about the water treatment process. We discussed with an expert from Carlsbad Desal Plant about the desalination process of ocean water. We watched some interesting videos at National Science Foundation.
Members of our team also met with 3 separate engineers, including an independent irrigation engineer, Mr. Ron Eckstein, for suggestions, feedback, and improvements to our design. We met with city planning staff to brief them on our concept for possible inclusion into the future City Hall landscaping design.
They gave us feedback for turning our concept into a formal proposal, and we will work with Mr. Dan Biggs to do this. We were interviewed by our local newspaper, and an article about our design was published last week.
Team Technobotic Dolphins 32799 presents Will, Ian, and Jonas as our curious minds, Orion as our sharp-looking cactus, and our 3 genius scientists are Taj, Kim, and Minji.
Finally, we present Grant as our
Fantastic narrator.
We're Team Technobotic Dolphins. Thanks for watching.